Welcome viewers, this is Mr. Dingo. I want to urge you to subscribe to our channel so that you support us in this endeavor of teaching our young children during this time of crisis when they are at home. And we have been told the exams will still go on, so this is their chance to be able to continue learning, and we hope you are going to make this learning process very easy for them. So that they can be able to study while at home. Now, in our previous lesson, we actually explained how to be able to convert trigonometric ratios into Surds. And we used that by looking at three angles. The three trigonometric ratios, that is cosine, sine, and tangent of 30, 45, and 60 degrees. So today with me here, we want to apply Surds in some of the questions that we are going to see. And one of the areas where we are going to apply Surds, the first question we are going to talk about is one dealing with what we talked about yesterday, which we talked about as the trigonometric ratios brought into Surds. Now we have the question 1 here: express 1 divided by 1 plus cos 30 in the form of a plus b Surd c, where a, b, and c are integers. Now, this cos 30 is not Surd, but surely we can get a Surd out of it. And I said when you have 30 degrees, sketch first of all an equilateral triangle, with the lengths 1 centimeters. So if I have, let me say 2 centimeters. So if this is 60, this is 60. Let me divide this into 2, so this is 30, this is also 30. We know if I divide this into 2, this will be 1 centimeter, this is 1 centimeters. Now, from yesterday, we also realized that we can be able to get this height. This height, we can't do without it. And that height there, we said, if we want to get it, we know that we have a right angle triangle here, where this is hypotenuse is 2, this is h, the opposite side, and this adjacent is 1. So we can say, for us to get h, we say h squared, use Pythagoras Theorem, plus 1 squared equals to 2 squared. And h squared will be equals to, this is 4. So 4, if I subtract 1, I'll get h squared equals 3. So square root of 3, square root of 3. So h here will be Surd 3. So our h here, we can say this height here is Surd 3. Now after we be able to determine that, then we can say we are told to get cos 30. Cosine of 30 degrees will be equal to, if cos 30 is here, cos 30 is equals to adjacent over hypotenuse. This is cos theta. Cos theta is equal to adjacent over hypotenuse, and our adjacent, if 30 is here, adjacent is Surd 3, hypotenuse is 2. So we can cos 30 degrees will be, adjacent is Surd 3 over 2. So once we have this, then we can therefore be able to replace, substitute, where we have Surd 3 over 2 for cos 30, we bring it here. So we are going to say, we are told to be able to deal with 1 over 1 plus Surd 3 over 2. So we have our Surd here. So as usual, we have to rationalize the denominator. To rationalize the denominator here, we said we look for the conjugate, and conjugate will be 1 minus Surd 3 over 2. So we say 1 over 1 plus Surd 3 over 2. We say we multiply by the conjugate, Surd 3 over 2. So whatever we do at the denominator, we do at the numerator. We said we multiply by the conjugate, Surd 3 over 2. So once we have this, viewers, we continue now to open the bracket. If open 1 times that will just be 1 minus Surd 3 over 2. But divide by, I said that this is like a difference of 2 squares. So 1 times 1 is 1, minus Surd 3 times Surd 3 is actually Surd 9. 2 times 2 is 4. So Surd 9 over 4, which we can say this is 1 minus Surd 3 over 2 divided by 1 minus 3 quarters. And we know that if I have 1 minus side 3 over 2, 1 minus 3/4 is a quarter here. So if I have to do this, we know that I can multiply this number by the reciprocal of a quarter, which is 4. So I'll say this is the same as 4 into 1 minus side 3 over 2. If I open this bracket, I'll get 4 minus 4 times this is 4 3 over side 3 over 2. But 2 can cancel 2 here, so I'll get 2 side 3. This is our answer, which is the same as 1 over 1 plus cosine of 30. And you realize you have put it in the form of a plus b side c, where a here is 4, b is -2, and c is 3. So viewers, you see that particular question. Let me give you a similar question of that. Let's try another one. Express, this is now 1 plus tan 60 degrees divided by 1 plus sine 60. So we have another question for us here. We have to try it again. So we realize that we have 1 plus tan 60 divided by 1 plus sine of 60. Now from our previous lesson, we can be able to get this, and like I've said, let us sketch an equilateral triangle. The equilateral triangle is 60. 60 is here, 60 degrees is here. Said we are allowed to bisect this one into 2, and if you bisect into 2, if this is 1, this is 1, this full side will be 2 centimeters. This is 1 centimeters, this 1 centimeters, this 2 centimeters. We know this is 30 because this line has bisected 60 into 2. That is also another 30. But in our case, we want tan 60. We know from our previous results that this is already side 3. We don't need to go back there again. So side 3, when we are supposed to get tan 60, let's get tan 60 from there. Tan 60 or tan theta, we know tan theta should be equals to opposite over adjacent. And opposite in this case, this is 60. The tan is opposite is here. The tan is opposite is here. Adjacent is here. So tan 60 degrees will be opposite is side 3 over adjacent is 1. So it means that tan 60 is simply side 3. We got our tan 60. So let's go to sine 60. The sine of theta, theta is our 60 here. The sine of theta is equal to opposite over hypotenuse. So if this is sine 60, opposite line is this, side 3, hypotenuse is this. So we are going to say, if you have sine 60 degrees, we are going to get side 3 over 2. Now we have our tan 60, we have our sine 60. We can then be able to substitute them here, so that we say that 1, instead of writing 1 plus tan 60, we put actually 1 plus side 3, because tan 60 is side 3, and then 1 plus sine 60, sine 60, side 3 over 2, so plus side 3 over 2. So now we have the side. We can move on to rationalize the denominator by multiplying by the conjugate of the denominator. So the conjugate of the denominator is going to be, the same, but the sign is minus here. So 1 minus side 3 over 2 divided by, again the denominator we multiply by its conjugate, 3 over 2 here, into 1 minus side 3 over 2. So if you want to open this bracket, let's open the bracket of the numerator, which is going to be 1 into 1 minus side 3 over 2 plus side 3 into 1 minus side 3 over 2 divided by, we know that we said this one is a difference of two squares, so 1 times 1 is 1, minus side 3 times side 3 is side 9 over 2 times 2 is 4. So this is 1 minus side 3 over 2 plus side 3. Side 3 times 1, then minus side 3 times side 3 is side 9 over, you assume this is 1 here, so 1 times 2 is 2. Everything divided by 1 minus 3 over 4. So let's see. 1, you realize that side 3 over 2, side 9 over 2 is actually 3 over 2. So you say 1 minus, let's do this somewhere, side 3, this is a half side 3 plus 1 side 3. So you're going to have 1 and a half side 3. No, it's actually minus. So let's do that somewhere here. We say LCM is 2, and this is 2 comes into 2 ones. 1 times negative side 3 is actually going to be negative side 3 plus 1 comes here 2 times. 2 times side 3 is 2 side 3. So minus, it's like 1 side 3 plus 2 side 3 is actually side 3 over 2. So we know that this plus this will be plus side 3 over 2 minus 3 over 2. Side 9 is 3 over 2. So 3 over 2 is like 1.5. So 1.5 minus 1 minus 1.5 is going to be minus a half. Now we have left down here is a quarter. It's a quarter down there. So if you take this, subtract from this, 1 minus 3 over 2 is actually a half. Negative a half plus side 3 over 2 divided by a quarter. But we said that if a number is divided by a fraction, it's the same multiplying that number by the reciprocal of that fraction. So the reciprocal of this fraction is 4. So it's actually, we are going to multiply 4 into negative a half plus side 3 over 2. This is going to be here 2, negative 2 plus 2 side 3. This is going to be our answer for this question. So viewers, you can see how to transform a ratio, trigonometric ratios, into surds until you are able to express your answer in the form of A, B, surd C. A plus B surd C, where A in this case is negative 2, B is 2, and our C here is 3. So we have seen how we can apply surds in this area. I want us now to go to example 3, where we are going to be able to apply surds in mensuration, in measurements. There are many other areas, but I'll just also do 2 examples which I consider to be very demanding or challenging. And the first one is here. This is our number 3 at the diagram. So viewers, we have a question here. And this question will require from us a lot of patience. These are cases where we can meet in examination are trying to be able to see whether we know surds. So the diagram shows a solid cylindrical wooden log, and the cylinder is here. The radius of the cylinder is 4 surd 3. The radius here. That is where we have 4 surd 3 centimeters. And the total surface area, you know that a solid now, total surface area is 56 pi surd 6 centimeters squared. Find the exact value for the height here. That's what they want us to get. And they want us to express that value of height in surd form. So if you have to express this value of height in surd form, what do we need to do? We need to know that the formula for cylinder, surface area of a cylinder, is total surface area for a closed cylinder is 2 pi r squared plus, after we get the 2 pi r squared for the top and the bottom, because one circle is pi r squared, another one is pi r squared. So if there are 2, is 2 pi r squared plus the curved surface is normally 2 pi r h. The curved surface, this curved surface here, is what is pi r h. That should give us the total surface area. So what we are going to do here, let me substitute, but I want to reverse the formula now by starting with this part here and then surface area follows. So I'm going to substitute what we have. If I start by saying 2 pi r squared, r is 4 surd 3 squared plus 2 pi r, our r is 4 surd 3 times height. We don't know height, equals to surface, total surface area, which is 56 pi surd 6. We have established our equation. All what remains now is to move forward with the equation. But I want to be able to eliminate something here quickly. What do I want to eliminate? I want to eliminate pi. I want to eliminate, let me eliminate 2 pi. So if I divide both sides by 2 pi, here 2 pi, here 2 pi. So what will I get? Pi and pi will go, pi and pi here will go, pi and pi there will go. What about 2? 2 and this 2 will also go, 2 and this 2 will also cancel. This 2 here will go here once, here 28. If I'm not wrong, 28 times 2 is 56. So 56 divided by 2 is 28. So out of that we are going to get 4 surd 3 squared plus 4 surd 3 h, putting that in bracket, equals to 28 surd 6. But there's something I can see here. I can also divide this term by 4 surd 3. I can divide everything here by 4 surd 3. If I divide everything by 4 surd 3, I divide this by 4 surd 3. I divide here by 4 surd 3. I divide this one by 4 surd 3. What will I get? There are 4 surd 3 times 4 surd 3 here. So if I divide this, I will get 1 4 surd 3. So this one will go here 4 surd 3 times. I will get this one is 4 surd 3 plus this 4 surd 3 and this 4 surd 3 will go. So I'll get h equals, what do I get here? What I get here is 4 can go here once, 4 can go here 7. But you realize that 6 surd 6 can also be written as surd 2 times surd 3. So if 6 surd 6 can be written as surd 2 times surd 3, then I am sure that this one, or let me write it there, 7 surd 6, and I say surd 6 can be written as surd 2 times surd 3. Everything divided by surd 3. So surd 3 here will cancel out surd 3. So here we'll get here is 4 surd 3 plus h equals 7 surd 2. So if I want to get h here will be 7 surd 2 minus 4 surd 3. So this is what the examiner wanted us to get. We were supposed to get the value of the height in terms of A surd 2 plus B surd 3. And as you can see here, we have been able to get 7 surd 2 minus 4 surd 3 as the value of height. Viewers, it was not very hard to get. If you are able to get this question and get the final answer, you are going to be able to see that what you did here was simply simplifying, nothing more. So viewers, this example 4, and example 4 says the diagram shows a right-angled triangle with sides x centimeters, 3 surd 2 centimeters, and 2 surd 5 centimeters. And as you can see in the diagram, this is the equation. We are told to find the exact value of x in surd form. And we know, since this is a right-angled triangle, the best way to get x is actually what we call Pythagoras Theorem. We know Pythagoras Theorem says if this is A, this is B, this is C, then we know that A squared plus B squared equals to C squared. So if I substitute here, our A is X, so X squared plus B is 3 sub 2 squared to give me what we call C is 2 sub 5 squared. So if that's what we need to get, we are supposed to say X squared here will be if I have to, will be 2 sub 5 squared minus 3 sub 2 squared. So X squared here is going to be 2 squared is 4, sub 5 squared is 5, minus 3 squared is 9 times sub 2 squared is 2. So we are going to get here X squared equals to 20 minus 18, and X squared is 2. So the value of X is the square root of both sides. X will be the surd of 2 centimeters. That is what we are asked, and that's what we got. So now let's try number 5, which is right side 80, number 5a, right side 80 in the form x side 5, where x is a positive integer. We know that this is actually a simplification of surds. So if you have side 80, we know that side 80 can be written as the surd of 16 by 5. And that one will be surd 16 by surd 5. And surd 16 is 4. So it's going to be 4 surd 5. Meaning, in our case here, x is 4. The second equation, we are told a rectangle has length of 1 plus surd 5. This is the rectangle. The length is 1 plus surd 5 centimeters. And an area, the area here is surd 80. But we also know that in our A, we have got surd 80 to be 4 surd 5. So calculate the width of the area of the rectangle in the form P plus Q surd 5, where P and Q are integers. We know that width of a rectangle should be area divided by length. So area over length will give us width. So meaning that we are going to get area is A surd 80, which I'm going to say is the same as 4 surd 5, divided by the length, which is 1 plus surd 5. So viewers, if you have this one, some students will say surd 5 and surd 5. That's not correct, because we need to first of all rationalize, because this is, if you cancel 5, where do you leave 1? So we need to rationalize by first of all saying 4 surd 5 times the conjugate of this is 1 minus surd 5 divided by 1 plus surd 5 times the conjugate, which is 1 minus surd 5. So we know that this will be 4 surd 5 minus, if you multiply that by that, we get 4 times surd 5 is 5, divided by, we know that this one will be 1 times 1 is 1 minus surd 5 times surd 5 is minus 5. So if we continue to work out this one out, we'll get, let me say 20. So 4 surd 5 minus 20, everything divided by negative 4. So negative 4 there, let me bring them. We are told to write the sign P plus Q surd 5. So let me bring negative 20 here. It's negative 20 plus 4 surd 5, everything divided by 4. So I know that this one can also be written as negative 4, sorry. This can be written as negative 20 over negative 4 plus 4 surd 5 over negative 4. So if I simplify further, negative 20 divided by negative 4 is positive 5 minus, because positive 4 divided by negative 4 will be negative 1, so negative outside 5. So the area here will be 5 minus add 5 centimeters, not centimeters squared because it is width. That is the width as we have it there. We cannot move further than that. Now, viewers, let's look at example 6, which is the final example. And before we go there, I want us to analyze this diagram to understand everything that is here. We know that there are two radius here. The big R let the big R be the radius of the larger circle, and the small r to be radius, to say r for radius of the larger circle, the small r to be radius of small circle. So we have capital R to be the radius of the larger circle, which should come from here, passing through the diagonal of the square up to the other part of the circumference. Then R should be the radius of the smaller circle, which actually is the same as this length. This length here is the same as R. This one also is the same as R. So we know that, meaning that BC from this length to this length is 2R. And also from B to C here is B is 2R, because this is radius, this is also radius. So we know that if I get the square root of this diagonal here, or this diagonal here, which is BD, and then I add R for the other one, and then I add this R here, I will get the radius of the bigger cycle. So if I try that, what I'm going to do is I'm going to say R, let me get the diagonal BD squared should be, BD squared should be 2R squared plus 2R squared. So let me say 2R squared plus 2R squared. This will give us the length BD. So if I want to get BD exactly, so BD squared will be 4R squared plus 4R squared. So BD squared, if I continue, will be 8R squared. That is my BD. So if I want to get the length BD, I will get the square root. So BD here will be 8R squared, so add 8R squared. But this add 8R squared, we can simplify it. We know that 8 is the same as 2 by 4. So I can say this is like same as 4R squared times 2, if I'm actually going to get this side. So 4R squared times 2. We know we can get the square root of 4R squared, which actually is 2R side 2. So I'm going to say BD therefore, and you come from here, you come here. BD therefore is 2R side 2. That is going to be my BD. But I said that if I add, for me to get capital R will be the bigger radius. It will be BD plus, we see R here, for us to get the radius which is starting from here to there. So we have got DBD, which is the diagonal. Then we need to add R here plus the other R to get the bigger radius. So I'm going to say that's actually not the bigger radius. That's going to be the diameter. So if I say the diameter BD plus 2R, I will get 2R, meaning radius times 2. So radius times 2 here, if I want to get the actual radius now, I'll say 2R here, which is the same as the diameter, is the same as the diameter of the bigger circle, is the same as BD, which we have said is going to be 2R side 2 plus 2R. But if you want to get the actual radius, we'll actually divide by 2, divide by 2, divide by 2. So radius of the bigger circle here is 2 here 1, 2 here 1. It will be R side 2 plus r. So what we can say therefore is that the radius of the bigger circle is given by radius plus radius sub 2. This is the radius of the bigger circle. Now if you get the radius of the bigger circle, we can actually get the area of the bigger circle. The area of the bigger circle is pi r squared. R squared. But we know that r is the same as this one here. So we'll say that area is therefore pi into, where r is, we put r plus r sub 2 squared. I want to open this bracket using the short method, which is r squared plus 2 times r. 2 times r is r. 2r times r is 2r squared, then times sub 2, which is sub 2 here, plus this one squared is r squared. Sub 2 squared is the same as 2. So what we are going to say here, this pi times r squared plus, this is 2r squared sub 2 plus, this is 2r squared. So if I add this, r squared plus 2r squared is 3r squared, that is pi into 3r squared plus 2r squared sub 2. This is the area of the bigger circle. But now I want to bring in the area of the smaller circle. We know we need 4 of them because the area of the bigger circle is here, we have got it here. But the total area of the 4 small circles, we know that this one small circle is pi r squared. But there are 4. So if there are 4, it will be 4 pi r squared. So this is the area of the 4 small squares. So if that's the area of the 4 small squares, then we are going to say, we are told to get the total area of the small square over this one. So we are going to say that is, let us have it, the 4 small squares is 4 r squared, 4 pi r squared, divided by pi into 3r squared plus 3r squared plus 2r squared sub 2. We know from here r and r can go. So viewers, let us get more space so that we can try to solve this problem. So once we have this one here, we know that now we have 4 r squared, everything divided by 3 r squared plus 2 r squared sub 2. So viewers, the first thing we need to go here when we are here is to factorize r squared so that we can find a way to eliminate it. And if we do that, we are going to have 4 r squared divided by r squared over 3 plus 2 sub 2. And this one will be, this r squared and r squared will cancel. So we'll get 4 divided by 3 plus 2 sub 2. Once we are here, it means we can now be able to rationalize the denominator by saying 4 times the conjugate of the denominator is 3 minus 2 sub 2 over 3 plus 2 sub 2 into 3 minus 2 sub 2. So we know that this will be 12 minus 8 sub 2, everything divided by we know that 3 times 3 is 9 minus 3, there's a difference of 2 squares, 3 times 3 is 9. 2 times 2 is 4, times add 2 times add 2 is 2. So we'll get 12 minus 8 add 2 divided by 9 minus 8. This is going to be 12 minus 8 add 2 divided by 1. So that could simply be the final answer as 12 minus 8 add 2. That is the answer for total area of 4 small squares, also 4 small circles. 4 small circles divided by the area of the larger circle. You realize that it's a long way. We see where we started from here, getting BD, which is the diagonal of the square. From BD, we are able to use BD with the radius here to be able to get the capital R, which is here. How to get that? You use that one to get the area, which we got to be here. So this is the area finally. And now we have the area of the 4 smaller circles divided by the area of the bigger circle. And then we come here to simplify, eliminate R squared, and then we end up with 4 divided by 3 plus 2 add 2. After that, we rationalize the denominator to get this, and finally we end up with 12 minus 8 add 2 in the form of A plus B add C. So thank you, viewers. That's the end of our lesson today. We have learned about surds. We are going to look at the next chapter, and we are going to decide soon what chapter we have. If you have any questions or concerns or any chapter you want us to do for you, please be able to comment in the comment section. We are going to find you so that we can be able to support you. Support us also by subscribing to our channel so that you can be able to grow together. Thank you.